Pattern-based or signature detection is the simplest triggering method as it monitors the network for a matching pattern using predefined signatures. A signature has three distinctive attributes: type, trigger, and action. The signature database is the heart of the system as it holds the signatures of known attacks and malicious behavior. A signature is either atomic or single packet, or composite or multi-packets. When there is a match, the device executes the corresponding action, alert, logging function, or sends an alarm to the management software. For the system to be most effective, the signature file must be updated on a regular basis. Cisco collects data on malware variants and new threats as they are discovered, and updates and creates signatures on a regular basis. The signatures are then distributed to clients according to the threat level. If the threat is severe, Cisco will publish the signature files within hours of identifying the threat. Less aggressive threats are published every 2 weeks. In addition to signatures for newly discovered threats, the signature update will include all the signatures from the previous version as well. To obtain the signature file, we'll go to cisco.com. You'll need to log in, and if you don't have an account, you can create one, and then we'll go to Downloads, Software Downloads, and here you can just see that there are some most popular, and we'll just click on one of those, and as you can see, signature updates. You would click on that and then log in with your username and password, and then you would have the latest signatures. If the system can obtain signatures automatically, it's best to set this option to ensure real-time threat defense. Using signature-based intrusion detection reduces the strain on the system, but it does have limitations when there are unknown attacks or variables that are unpredictable, such as ports used by Trojans and their associated processes, which can randomly grab ports. The signature database is the heart of the intrusion detection system. For the system to be most effective, the signature file must be updated regularly. When there is a signature match, the intrusion detection intrusion prevention system executes the corresponding action, alert, or logging function. The signature can trigger any of the following actions. It can generate an alert. An atomic alert is generated every time a signature triggers. A summary alert is a single alert that indicates multiple occurrences of the same signature from the same source, address, or port. It can log the activity so it can be analyzed later in more detail. For example, using a honeypot-based intrusion detection where the network administrator is simply monitoring the activity. It can drop and prevent the activity. This can stop an attack before it has a chance to perform malicious activity. It could reset a TCP connection to terminate a session that is suspicious, which you might see the initial SYN packet come in and a SYN-ACK, but the intrusion prevention system will send a reset and stop the connection before it does any damage. It can also block future activity. It will drop the packet and all future packets from the TCP flow by updating the access control list on one of the infrastructure devices, and it may allow the activity. Now this sounds odd, but this does happen. For example, when the administrator needs to allow exceptions to configured signatures. This might happen possibly during an authorized event, such as a vulnerability scan. Each rule header includes a parameter that specifies the action the system takes when it matches a signature. A rule that is set to alert will generate an intrusion event and log the event. Rules that are set to pass will simply allow the packet to pass with no other action taken. Pass rules by default will override alert rules. An alarm will trigger when a specific parameter is met. Triggering can also generate false positives or false negatives. If this happens, the administrator must study the existing network traffic and then tune the signatures to get a more accurate result. Events can occur throughout the network. Event correlation is a powerful process of simultaneously monitoring activity throughout the network to detect patterns or events that might be malicious. To effectively correlate all events, it's best to use network time protocol or some other time synchronization protocol among all devices so that they all have the same system time. By using consistent timestamps, the network administrator can more accurately determine when specific network events happen in relationship to other events. The device will signal an event, however, the security staff must respond quickly to assess the threat level. If the system is compromised, the security staff must work quickly to restore to a normal state as quickly as possible. When there is a signature match, the intrusion detection system will execute a corresponding action, alert, or logging function. Event correlation monitors activity throughout the network to detect patterns of events that might be malicious. In the case of an event, the incident response team brings the systems back to a normal state. During normal network activity, you may run into malicious websites. One way to deal with malicious traffic is using either a blacklist or a whitelist. A blacklist is an access control method that allows all traffic except the traffic on the list. A whitelist is an access control method that denies all traffic except the traffic on the list. A blacklist can be a valuable resource to reduce risk by denying access to potential malicious traffic that can include websites, hosts and usernames, TCP and UDP ports, ICMP types and codes, and specific file extensions. A whitelist restricts access to only trusted objects. An example would be MAC address filtering on a wireless access point. Creating a whitelist is more granular and cumbersome, especially if there is a large number of entities that need to be added to the list. However, it does reduce the number of false positives that involve known benign traffic. Because it's so cumbersome, blacklisting is used more often. The list can either be static or dynamic. If you participate in the Cisco Global Correlation Network, that will send your statistics to the Threat Operations Center for analysis, and the results will be distributed to the global community and update the device's dynamic database. In addition, you can also manually add entries to a static blacklist. One type of threat we take very seriously is botnet activity. Now, this can occur if an internal host is infected and tries to communicate with other members of the bot, which are most likely malicious. The botnet traffic filter address categories include known malware addresses. These addresses are on the blacklist identified by the dynamic database and the static blacklist. Known allowed addresses. These addresses are on the whitelist. Ambiguous addresses are associated with multiple domain names, but not all the domain names are on the blacklist. We also call this the gray list. Unlisted addresses are unknown, and they're not included on any list. I wanted to take you to this website to show you common Trojan ports. There are many websites like this, but it would be good for you to familiarize yourself with websites like this, so if you are concerned about some suspicious port activity, you can reference these. In addition, this website tells us about threat detection in the community. Here we can go to Reputation Lookup and search by IP, domain, or network owner for real-time threat data. I'll scroll down here and you can see some information as far as legitimate email, spam, or malware, and we can click on a marker to see more information. Here it talks about the IP address and the host name and the email type, and in this one it's showing malware. So one way to deal with possible malicious activity is by using blacklists, which allows all traffic except the traffic on the list, and whitelists, which restricts access to only trusted objects. When there is a signature match, the device executes the corresponding action, alert, or logging function. The alarm can be false positives or false negatives, which may have to be modified or tuned to get a more accurate result. There are 4 types of alarms. A false positive alarm is when the system generates an alarm when processing normal benign traffic. A false negative is when an intrusion system fails to generate an alarm after processing attack traffic that the system is configured to detect. False negatives are dangerous as the system is not detecting known attacks. A true positive is when the system generates an alarm in response to known malicious traffic. A true negative is normal network traffic that does not generate an alarm. The goal is to generate true positive alarms. To minimize false positives and false negatives, the administrator should study existing network traffic and then tune the signatures to better recognize intrusion patterns. A signature is tuned to one of 4 levels based on the perceived severity of the signature. High. An immediate threat is extremely likely. Possible attacks to gain access or cause a denial of service are detected. Medium. An immediate threat is likely as abnormal network activity is detected that could be perceived as malicious. Low. An immediate threat is not likely. However, abnormal network activity is detected that could be perceived as malicious. Informational. Activity that triggers the signature is not considered an immediate threat. However, the information provided is useful information. An intrusion detection and intrusion prevention system has 4 types of alarms: false positive, false negative, true positive, and true negative. A signature is tuned to one of 4 levels based on the perceived severity of the signature. The goal is to generate true positive alarms in response to known malicious